Here's a lesson for section 8.2, area and or perimeter of composite figures. So before we start this lesson, make sure you've gone to jensenmath.ca, you've printed off this lesson so you can follow along and copy down as we go through, and then you can try the worksheet after to practice the skills we learn. So to get started, okay, so we want to find the area of composite figures. First of all, what is a composite figure? A composite figure is a figure formed by combining simple shapes. So you could calculate the area of a composite figure by finding the area of each of the shapes that make up this composite figure and then adding them all together. So I've made a composite figure here. Remember, a composite figure is a figure made up of combining simple shapes. So I've got a bunch of simple shapes here. I got a triangle here, a rectangle here, and a semicircle here. And I've made up one composite figure by adding all of these shapes together. If I wanted to find the area of this composite figure, I would find the area of each of these individual shapes and add them all together. So let's do an example where we'll actually do something very similar to this. I'll give you a composite figure, so a figure made up of two or more simple shapes, and then we'll then find the area of that by adding those areas together. So let's do that. Before we do that, just a quick reminder of what some of the formulas we'll be using are. I don't know why it's lagging like that. But, so if you want to find the area of a rectangle, you'll need to do length times width. If you want to find the area of a triangle, this looks all cluttery there. Okay, area of a rectangle, length times width. If you want to find the area of a triangle, you'll need to do half times the base times the height, or base times height divided by 2. Both are equivalent, whichever one you would prefer. If you want to find the area of a circle, you're going to have to do pi r squared. If you want to find the perimeter of a circle, you'll have to use the formula 2 pi r or pi d, depending on if it gives you the radius or the diameter. Why can we use either? Well, the diameter of a circle is equal to 2 times the radius. That's why these formulas are equivalent. 2 pi r is the same as pi d, because the diameter is equal to 2 times the radius, or conversely, the radius is half of the diameter. Okay, here's our first example. I give you a composite figure, so a figure made up of two or more simple shapes. I want you to find the area of that composite figure by finding the area of each of the shapes it's made up of, then adding them together. So first thing we have to do, we have to figure, okay, what two shapes is this figure made up of? So hopefully you're able to see, I've separated them by color. The green figure is a rectangle, the purple figure is half of a circle, or what we'll call a semicircle. So identify the shapes that make up the figure. Well, I've got a rectangle, and I'll just roughly sketch it below. I've got my rectangle, and its dimensions are, it's 2.4 by 3.8, and those are in meters. And I've also got a semicircle. Semicircle. I'll just roughly sketch that and label what I know. So I've got a semicircle. If you look carefully at the diagram, you'll notice it gives us the diameter of the semicircle is 2.4 meters. So it gives me the diameter, which is 2.4 meters. Okay. So now if I want to find the area of this composite figure, I'm going to need to find the area of both of these shapes. I'm going to need to find the area of this rectangle, the area of this semicircle, add them together, and that will give me the area of this whole figure. So let's do that. Let's first find the area of the semicircle. Well, how do I find the area of half of a circle? Well, I know how to find the area of a full circle. The area of a full circle is equal to pi r squared. If I want to find the area of a semicircle, the area of a semicircle is half the area of a circle, so I need to find the area of the full circle and then divide that by 2 to get the area of half of the circle, or the semicircle. So area of a semicircle equals pi r squared divided by 2. So the area of a full circle divided by 2. Okay, so to find the area of this, the only variable I need to know is the radius. If we look back at our diagram, it doesn't give us the radius, it gives us the diameter. But that's okay. I know the radius is half of the diameter. I know radius equals diameter divided by 2. I know the diameter is 2.4. Half of 2.4 is 1.2. So I know the radius is 1.2 meters. So let's plug that in. So pi times 1.2 squared, divide that by 2, and let's figure out our answer. So pi times 1.2 squared, pi times 1.2 squared, that'll give me the area of a full circle, which is 4.523 2.89 meters squared, but I want the area of the semicircle, so I have to divide that in half, so divide it by 2, and I figure out the area of the semicircle is 2.3 meters squared, if I round it to the nearest tenth of a meter squared. Now let's find the area of the rectangle. The area of the rectangle, it was, well, the dimensions were 2.4 by 3.8, I believe. Was it 3.8? Yes, it was 3.8. Okay, so I know both the dimensions. Let me zoom in on this rectangle here. Let's find the area of this rectangle. I know the area of a rectangle. Area of a rectangle equals the length times the width. I know both of those pieces of information. I've got my length, I have my width. Plug that in to figure out the area of the rectangle. So 3.8 times 2.4. If I find that product, that will give me the area of that rectangle. 3.8 times 2.4 will give me 9.1. If I round it to the nearest tenth, 9.1 meters squared. Okay, good. So I now know the area of both of the figures that make up my composite figure. Now let's actually figure, okay, well, what is the total area of the composite figure? So I just got to add these two areas together. So the total area is equal to the area of the semicircle plus the area of the rectangle. And I know both of those pieces of information. The area of the semicircle was 2.3 meters squared, and the area of the rectangle was 9.1 meters squared. So that gives me 11.4 meters squared. That's the total area of the composite figure. Okay, so that question is now done. The area of the figure is 11.4 meters squared. Those ones are nice and easy to do. When you've got a composite figure that's made up of, two or more figures, just find the area of each of the figures, add them together, that'll give you the total area of your composite figure. Sometimes you'll have to follow a little bit of a different method. For example, I have this question here. Find the area of this hang glider sail. If you tried to do this one the way we did the last one, you might think, okay, I could divide this into two triangles, try and figure out the area of this triangle, add them together. But in this case, we don't have the information needed to do that. What you'll have to do for this question, and what you'll have to do for some other questions when we find the area of composite figures, you might actually have to construct a bigger figure and then subtract a piece of that figure that has been cut out. Okay, so let's look at this. If I was to construct a bigger triangle, so draw a line across here, I have enough information to figure out the area of this whole thing. I can figure out the area of this whole thing. But the figure that I want to find the area of isn't this figure that I've just shaded in. I don't want the area of this part here. So think of this part as being cut out. So all we have to do is we have to figure out the area of this whole thing that I've just constructed, figure out this whole area using, I have the base of the triangle, I have the height of the triangle, so I can find the area by doing base times height divided by 2. And then what I can do is subtract the area of this little triangle that has been cut out. So I can find the area of that triangle because I have the base, and I also have the height of that little triangle. So I could subtract the area of that from the area of the big one that I've constructed, and that will tell me the area of just this part of the hang glider sail, which is what I want. Okay, so determine how we can find the area of the sail. So what I'm going to do, I'm going to find area of the big triangle that I constructed, big triangle. So I'll draw it below and label what I know. I know the base of it is 3.2 meters. Let me just zoom in a bit here. So I'll find the area of the big triangle and then subtract the area of the small triangle that's been cut out. And I'll draw that. Oh, I forgot to label the height of the other one. I'll do that after. And then I want to subtract the area of this. The base of that is 3.2. And the height of that is 0.6. The height of this other triangle was 3.8. Okay, so let's do that. Let's find the area of the big triangle that I'm going to construct. So let's find the area of this whole thing. Okay, so I'll do that on the other side. So area of the big triangle equals base times height divided by 2. Look back at what we know. I know the base and I know the height. Here's the base, here's the height. Let's plug that into our formula. So 3.2 times 3.8, and then divide that product by 2. And let's see what I get. 3.2 times 3.8. I get 12.16. Divide that product by 2. I get 6.08. I'll round that to the nearest tenth and get 6.1 meters squared. Are we in meters? I forgot to check. Yes, we are in meters. Okay. Now let's find the area of the small triangle. Area of the small triangle. Well, it's also a triangle, so I can use the formula base times height divided by 2. The base is the same. It's 3.2. But if I look back at my diagram, the height of the smaller triangle is only 0.6. So 0.6. And now I need to divide that by 2. And let's calculate that. 3.2 times 0.6 will give me 1.92. I need to divide that product by 2, and I get 0.96. I'll round that to 1.0. 1.0 meters squared. Now what I'm going to do, I'm going to actually calculate the total area by subtracting that small triangle that's been cut out from the area of the big triangle that I constructed. So find the total area. So total area. I said I find that by taking the area of the big triangle and then subtracting the area of the small triangle. So let's go ahead and do that. The area of the big triangle was 6.1. The area of the small triangle was 1.0. I get 5.1 meters squared is the total area of that hang glider sail. Okay, next question. For this one, not only am I going to find the area of a composite figure, I'm also going to find the perimeter of the composite figure. And hopefully you remember the definition of the perimeter of an object is the sum of the lengths of the outside sides of an object. So in order to find the perimeter of this object, I'm going to first have to find the length of the unknown sides of this object. So I'm going to have to add them all together to figure out the perimeter. So a lot of these side lengths have been labeled. For example, the top side length is 10. This side is 7. Well, okay, that also means that this side is 7. It's told me that this section here is 3 meters in length. If the whole part would be 7, that tells me that both of these inside parts, this one and this one, must both be 4. And then I know this whole length is 10. This part is 2, this part is 2, so that means that this part must be 10, and then subtract the 2 and the 2, which would give me 6. And then I think those are all of the unknown side lengths. Good. I could then find the perimeter of this object by adding up all of the outside sides. So I'll highlight what I would have to add. I have to add up this one, 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 and this one. Don't make the mistake of actually adding in this 3 as well. This little part here that it's labeled isn't on the outside of the object, so we don't add that for the perimeter. Okay, so I think part B is going to ask us to find the perimeter. Yeah, find the perimeter of the object. So let's just add up all of the outside sides. So perimeter equals, I'll start here. So 7 plus 10 plus 7, I'll write that. 7 plus 10 plus 7 plus 2 plus 4 plus 6. So plus 2 plus 4 plus 6 plus 4 plus 2. And I've circled each of them as I went through them, so I didn't leave any of them out, and I didn't actually count any of them twice. Well, let's add these all together and find the sum. 7 plus 10 plus 7 is 24, plus 2 is 26, plus 4 is 30, plus 6 is 36, plus 4 is 40, plus 2 is 42. So the perimeter of this object is 42 meters. Part C says find the area of the object. Okay, there's a couple ways I could find the area of this object. I'm just going to kind of, 42, this was 42 meters. Sorry, I didn't mean to erase that. Okay, there's a couple ways I could find the area of this object. I'm just going to erase all of this stuff. So I'd figured out that these inside sides were 4 and this one was 6. If I wanted to find the area of this whole object, there's a couple ways I could do this. I could divide this into simple shapes and then find the area of each of the shapes. I could find the area of this rectangle, I could find the area of this inside, this one here, and then the area of this rectangle, and then add them all together, and that would be the area of my composite figure. I could do that. How I'm going to want to do this, I'm going to do this one similar to how I did the example 2 with the hang glider sail. I'm going to construct a bigger rectangle, construct it by adding in a line here, and then finding the area of this whole rectangle, and then subtracting the area of this little rectangle on the inside here that has been cut out, and that will tell me the area of just the part here, which is what I want. Okay, so let's do that. If I want to find the big area, so I'll find the area of the object, I'll find the area of the big rectangle first, so of this whole thing that I'm going to construct, find the area of the big rectangle, that's equal to length times width, which equals, well, it gives me the length and the width. I'll just erase all these scribbles here. It gives me the length and the width of the big rectangle. So here's my big rectangle that I constructed. It gives me the length and the width. It gives me 10 and 7 as my length and my width. I'm just going to zoom in so you can see that a little bit better. So it gives me 10 and 7 as my length and my width. So I can plug that in to my formula. And I get 10 times 7, which is 70 meters squared. If I now want to find the area of the smaller rectangle that has been cut out, I can do that. So now let's just look at the smaller rectangle that has been cut out from that bigger rectangle, and let's figure out the length and the width of that one. Well, I told you this had a length of 6, because this whole thing was 10, these parts were 2, subtract the 2 and the 2 from the 10, and we got 6. And I know this length on the side here is 4, because this length is 3, the whole thing is 7, 7 minus 3 is 4, that's how I figured out that this length here is 4. So, to find the area of the smaller rectangle, so area of small rectangle is equal to length times width. My length and my width are 6 and 4. 6 times 4, that gives me 24 meters squared. If I want to find the area of the object that's drawn, the total area, so area total equals area of the big rectangle that I constructed, then I must subtract the area of the small rectangle that has been cut out from the rectangle I constructed. So that equals 70 minus 24, and that gives me 46 meters squared. So I now have the area of the object that was drawn originally. Okay, so here's my final answer: 46 meters squared. Let's move on to the next question. Last question that we'll do. A hotel is remodeling its outdoor entrance area. The new design includes a tile walkway leading to a semicircular fountain. So that's key here. It tells us that it leads to a semicircular fountain. What steps would you take to find the area of the walkway? Well, how I would do this one, what I would do, I would construct a rectangle. So I've got my rectangle here. I could find the area of that, but so I'll find the area of that rectangle. I'll find the area of the rectangle. But then I'm going to notice the walkway isn't just a full rectangle. It's got the little semicircle that's been cut out from it. Okay, that little semicircle, because it leads to a semicircular fountain. That semicircle has been cut out from my rectangle. So I'm going to need to find the area of that semicircle and subtract it from the area of my rectangle. So I'm going to subtract the area of the semicircle. Okay, so let's go ahead and do that. B, actually calculate the area of the walkway. round to the nearest tenth. So I'm going to have to find the area of the rectangle. So I'll do that first. Area of the rectangle. I know the area of a rectangle equals length times width. Let's look at the diagram, and it gives me the length and the width. It gives me my length and my width. So remember, first part, we're finding the area of this whole big rectangle, this whole thing. It gives me length and the width, 5.2 times 2.1. So 5.2 times 2.1. And then I'm going to find that product. It'll give me 10.92. Whoops. 10.92. And are we in meters? Yep, we're in meters. So 10.92 meters squared. Area is always in units squared. Now I'm going to need to find the area of the semicircle. So remember, the area of a circle is pi r squared. A semicircle is half of a circle, so I'm going to need to divide that in two to find the area of the semicircle. So area of my semicircle, let me just erase this rectangle that I constructed so that I can see the semicircle that I must subtract from that. So now I need to subtract the area of the semicircle that has been cut out from it. So let me just draw my diagrams under here. So I had the area of my rectangle, which was 2.1 by 5.2. Now I need to subtract the area of the semicircle. I've got the diameter. The diameter of the semicircle is 2.1. I'm going to need the radius eventually when I actually calculate the area, but I'll do that on the other page. So let's go ahead and do that. I'm now going to need to find the area of my semicircle. I know the area of a semicircle equals pi r squared divided by 2. I'm going to need the radius. I need to plug in for r. Unfortunately, it only gives me my diameter. But I remember the radius equals half of the diameter, so half of 2.1, which is 1.05. So I can plug that into my formula. Pi times 1.05 squared, and then divide that product in half because I only have half of a circle. And let's go ahead and do that. So pi times 1.05 squared, and I get 3.4636. That would give me the area of a full circle. I want area of the semicircle, so half of that divided by 2, I get 1.7318. I'll round to the nearest hundredth right now, so to 2 decimal places, 1.73 meters squared. Now, if I want to find the area of, it's a walkway, I believe. Yeah, it's a walkway. I know I'm going to have to do the area of the rectangle and then subtract the area of the semicircle because the semicircle has been cut out from that rectangle. So let's go ahead and do that. My total area, let me zoom in again. So my total area, so area total equals the area of the rectangle minus the area of the semicircle. The area of my rectangle was 10.92 meters squared. Subtract the area of the semicircle, which is 1.73 meters squared. And when I subtract the area of that semicircle that has been cut out from the area of my rectangle, I will get the area of the walkway. So 10.92 minus 1.73. That will give me 9.19. I'll round to the nearest tenth. 9.2 meters squared. Did it tell me what to round to in the question? I don't believe so, so I'll just leave it to the nearest tenth. That's fine. Oh yeah, it did say round to the nearest tenth right here. Okay, good. So I round to the nearest tenth. My final area, 9.2 meters squared. I think the last thing we're going to do now, it says we're now going to find the perimeter of that walkway. So the walkway will have a border in a different color of tile. Calculate the perimeter of the walkway round to the nearest tenth of a meter. Okay, so I now want to find the perimeter of this walkway. So I'm just going to erase what I've drawn around this diagram here. If I want to find the perimeter of this walkway, I've got most of what I need to state the perimeter. Remember, perimeter is the length of all the outside sides added together. Well, I've got this side, it's 2.1. This one is 5.2. That means this one is also 5.2. Okay. So the only side I don't know the length of is the curved side. I don't know the length of this. But remember, that's a semicircle. What I could do is find the perimeter or the circumference of the full circle and then divide it in half. So get rid of half of it, and that'll tell me the perimeter of just that part there. Okay, the perimeter of that part of the semicircle. So let's go ahead and do that. So let's first find, I'll find the perimeter of that semicircle that I'm going to need to add to it. So perimeter of the semicircle, that equals the perimeter of the full circle, and then divide it in half. Perimeter of a full circle is pi d. I need to then divide that in half. So I know the diameter of the circle. If I look back, the diameter of the circle was 2.1. So let me put that in. Pi times 2.1. I'm going to then need to divide that result by 2. So I'm going to have pi times 2.1 and then divide that product by 2. That'll give me 3.3. When I round to the nearest 10, 3.3 meters. Good, so I now have the part that I have drawn in red here. I now have the length of this part right here. That part right there was 3.3 meters. So now all I have to do, I have to add up all of the outside sides, all 4 of those, and that will give me the total perimeter. So let me do that. So the perimeter total equals 3.3 plus 5.2 plus 5.2 plus 2.1. Add all of those together, so I have 3.3 plus 5.2 plus another 5.2 plus a 2.1, and I get 15.8 meters, and that's my total perimeter of the walkway. So you'd write the total perimeter of your walkway is 15.8 meters, and that's round to the nearest tenth. Remember, nearest tenth means 1 decimal place, and that's what I've done. Okay, so that's it. Make sure you get the worksheet from jensenmath.ca, and you practice what we've learned here. Okay, let me know if you have any questions.